All right, here is example 2 for lesson 2 in unit 5. Example 2 says carbon dioxide or CO2 emissions contribute to climate change, and so they are closely monitored by governments and environmental groups. The following two graphs represent CO2 emissions worldwide from 1995 to 2005. So we've got two graphs here. The first graph is carbon dioxide emissions by year. The second graph is the same. Notice that these are horizontal bar graphs. These are not vertical bar graphs. For the first graph, the year is on the y-axis, and it's the same for the second graph. And then similarly, the x-axis is the same, carbon dioxide emissions in billions of tons on the bottom for both. But what do you notice that is different about each graph? Well, the first graph, the scale on the x-axis goes from 0 to 30. And on the second one, the scale goes from 20 to 27 and a half. So the scale is very different. And you'll see that our data, as a result, in the first graph, our data is not spread out as much. You can see that from here, my first line, to here is a lot less of a gap, right, than it is in our second graph. From here to here, you see the gap is much more is much wider, and so that's the main difference between these two graphs. We've got some questions that we're going to have to answer based on this. Okay, so A says, which graph is a better representation of worldwide CO2 emissions and why? Well, my answer is the second graph is a better representation because the scale gives a more accurate picture of the rise in CO2 emissions. The first graph might mislead you to believe the rise has been pretty gradual, but the second graph there actually gives us a really good indicator that from 1995 to 2005, we've had a really large change. So from 21 and a half all the way to just under 27 and a half billions of tons. And so we've actually had a pretty large change in 10 years, as opposed to the first graph where it seems like it might be a smaller change. B says, what were the emissions in 1999? Okay, so if we look at both graphs, the second one will be more accurate. It'll give us a more of an accurate depiction of what that number actually will be. And what we have to do is we have to look at 23.0 and 24 and a half. Here's my data point for 1999. I'm almost directly halfway between 23 and 24 and a half. And to find that number, you can average 23 and 24 and a half, which means I can take 23, add 24 and a half, and then divide that whole thing by 2. Okay, we will get 23.75. And so this bar represents 23.75. And so in 1999, I'm just below, my answer would be just under 23.75 billion tons. Whereas if we look at the first graph here, you could get, again, a general estimate in 1999. It's between 20 and 25, and it's slightly closer to 25. And so you might say 23, maybe you say 24. It depends on what you're looking at. But can you see that the second graph is more accurate? C says, what were they in 2005? Well, in 2005, let me erase this here. In 2005, again, I'm going to use the second graph because it's a little bit more accurate. Here is my data point. It's just below 27.5 billion tons. So that's what I would say. See, just under 27.5 billion tons. And D, why might the more misleading graph be used to represent the data? Well, you could come up with a number of answers for this as long as they make sense. My answer was if someone were trying to misrepresent the data, for instance, if they were trying to say the emissions were rising but very slowly, so this data here would help them use that argument. And so you have to, this is a good indicator, guys. You have to be very, very careful about reading graphs and reading data, especially online. I mean, there's so much stuff out there, about COVID-19 and, just about a lot of different topics that you have to read. You have to be able to actually understand what you're reading. And so this is a good example of the way data can be represented or misrepresented based on what point you might want to try and get across. If you use the first graph, you might be able to say that, look, carbon emissions aren't really rising that much. If you look at the second graph, you might be able to make the argument that carbon emissions are rising quite drastically. It kind of depends on what argument you want to make. And so all I'm saying to you is that when you're reading data, you really, really have to be careful about the data that you're reading. I hope that makes sense.